This old laptop charger looks completely useless, but with a few simple parts, it can generate intense heat for small metal repairs. Let me show you how this works. Take a closer look at the charger first. The label shows 24 volts and 2.5 amps. That tells us this unit can deliver stable low voltage with enough current to generate heat. The connector at the end is damaged, and that explains why someone threw it away. However, the internal power supply still looks intact. Carefully cut the outer insulation and expose the wires inside. Then plug the charger into a 220-volt outlet and watch the LED indicator. It lights up, but that only confirms power, not performance. Now bring in a multimeter. Switch it to voltage mode and place the probes on the output wires. Hold steady and wait for the reading. It shows about 24 volts. That confirms the charger still delivers proper output. This is the kind of diagnostic thinking that saves time. Instead of guessing, each step gets verified before moving forward. Before touching anything else, unplug the charger. Working on live wires always carries risk. Even low voltage systems can create sparks if the wires touch each other. A short circuit can generate heat instantly and damage insulation. Next, prepare 2 extension wires, one red and one white. Strip both ends and twist the copper strands tightly. Then connect them to the charger output wires. Rotate the strands slowly and press them together so they form a strong connection. A loose joint creates resistance, and resistance in the wrong place produces unwanted heat. Slide heat shrink tubing over the joint and apply heat evenly. The tubing contracts and seals the exposed metal. This step improves safety and keeps the connection stable over time. Repeat the same process for the second wire. Now the charger has extended leads that feel clean and secure. Move on to the alligator clips. Strip a short section of insulation and insert the copper into the metal slot. Press it firmly with pliers until it locks in place. These clips create temporary connections, which makes the tool more flexible. Give it a light pull. If nothing moves, the connection is solid. Now build the heating core using a spark plug. Take a terminal block and remove the screws and the brass insert. This small brass piece plays an important role. Brass conducts electricity well and transfers heat efficiently. Attach it to the spark plug and tighten it down. Then connect the red wire to this brass piece. This creates a direct path for current into the heating element. Run the wire along the body of the spark plug and secure it with electrical tape. Keep the wrap tight and neat so nothing shifts during use. Then grab a wooden clothespin and clamp it around the lower part of the spark plug. Wood acts as an insulator and protects the hand from heat. Add a zip tie to secure it even more. Now the tool feels stable and safe to hold. Next comes the most important part, the carbon rod. Take an old battery and carefully remove the outer shell. Work slowly with pliers to avoid crushing the inside. Then cut through the plastic wrap and remove the inner seal. Finally, pull out the carbon rod using a steady motion. At this point, it's important to understand something. Many people throw old batteries into regular trash without thinking about the impact. Inside these batteries, there are chemicals and heavy metals that can leak into soil and water. Over time, they contaminate the environment and affect human health. Reusing parts like this carbon rod reduces waste and gives new life to something that would otherwise become pollution. Set the carbon rod aside and continue with the battery casing. This part contains zinc, which reacts with acid. Cut it into small pieces and place them into a glass container. Then add a small amount of 22% hydrochloric acid. Bubbles start forming immediately. This reaction releases hydrogen gas and creates zinc chloride. This solution works as a flux. It removes oxidation from metal surfaces and helps molten material bond more effectively. If solder does not stick well, oxidation is usually the reason. A clean surface allows the metal to flow and form a strong joint. Let this mixture react for several hours so it becomes fully effective. Now return to the carbon rod. Insert it into a drill and spin it against sandpaper. Guide it slowly and shape the tip into a fine point. A sharper tip concentrates heat into a smaller area. That means higher temperature at the contact point and better control during use. Once the rod is ready, insert it into the brass connector on the spark plug and tighten it. Then connect the second wire to the alligator clip. This completes the circuit. Now comes the moment of truth. Plug the charger back into the outlet. Bring the carbon tip close to the alligator clip. As soon as they touch, sparks appear and the tip glows red hot. That shows the current flows correctly and the heat builds where it should. Before moving on, where are you watching from? And have you ever turned old electronics into useful tools like this? Share your experience. There is always something new to learn from different approaches. Now move to testing. Start with a metal cup that has a broken handle. Apply a small amount of the zinc chloride solution to the joint. This prepares the surface. Then bring the carbon tip into contact. Heat builds quickly, and the metal begins to soften. Hold it steady and let the material fuse together. After a few seconds, remove the heat and let it cool. The handle feels solid again. Next, test it on a bolt and a metal washer. Apply the same process. Heat spreads across the contact point and bonds the pieces together. Apply pressure to test the strength, and it holds firmly. Finally, test it on a battery casing. Apply the solution and bring the tip close. The metal reacts quickly. Heat melts through the surface and creates a strong bond. This shows the tool can handle different materials effectively. This project proves that simple components can turn into practical tools. Instead of throwing things away, take a closer look and find new uses. If this gave you a useful idea, share your thoughts in the comments. And if practical projects like this interest you, subscribe to the channel so you don't miss what comes next.